Swayam Prabha. Digital India. Educated India.
Welcome back. So we started talking about ambiguities and how this system can actually handle ambiguity. Ambiguity is mainly of two types in a natural language. So the first kind is the semantic ambiguity, and the second type is the syntactic ambiguity. So semantic ambiguity, for example, is, say, consider the word bank. So if the context is not clear, we don't know whether bank means the financial bank or the river bank. So this is semantic ambiguity. It's about the meaning of this word because it has multiple meanings. For us, what is more important, we do not have much of semantic ambiguity here because we have a very well defined glossary in this language, that is, I mean language L1E, but we have syntactic ambiguity here. What I mean by that is, here is a very famous example. You have a structure like stout Major's wife. Consider this structure. The problem with this structure is it can be understood, it can be interpreted in two different ways. One, stout and then Major's wife, where the wife is stout. The other one is where the major is stout. So you can have something like stout Major's wife. They are not the same thing. It is evident that they are different things. Now this is structural ambiguity because they have different structures, and now the semantic element comes, or rather depends on the structure. So if this is the structure, then the semantic element will be one thing, and then if the other one is the structure, it will be something very different. So this is what we have to keep in mind, that when we talk about ambiguities here in this context, we do talk about the structural ambiguity. Now let us consider a sentence, the sentence that is given here: every man loves some woman. It can have two different meanings. One, that is, there is at least some woman, or at least one woman, or one or more women, that is a set of women, such that every man loves her or them. So one picture could be something like one woman, and then there are many men, and every man loves that woman. This is one picture. So what is the interpretation here? You can very well see that if you want to translate this into the language of logic, it will be something like: there exists an x such that it is a woman, and for all y such that y is a man, L y x. This will be the symbolic meaning for this. We already saw this in one of the previous lectures, but there is also another possibility. It could also be this picture, that for every man there is some woman, maybe some women he loves. So M2 let him have just W2, and M3, W1, M4, once again W2, whatever. So, the point is every man is such that he has at least one woman he loves. So, you can see that there are two different pictures, and accordingly there are two different interpretations. This is like this, and this one is like this. The derivation is pretty much the same. That is, it must be the same. First, loves V2, that is loves plus V2. V2 is a name. V2 is a term. So that makes loves V2, and then V1. So you are. So this part is actually rule 2, the syntactic rule, and this part is rule 1, which deals with one VI and one name. Name, what I mean by name is a term, and then this is a product of these two rules. And then here at this stage we add man to this. So, man with respect to the variable V1, and we are using rule B5 here, the syntactic rule B5 here. As a result, we get every man loves V2. See here, V2 is still free. Now, then finally, every man loves V2 will have woman, and then the same. Sorry, it is B6. You get every man loves some woman. Now, the point is the derivation. This is one kind of derivation. Also, it could be the order could be slightly different. First, V1, first V2 and woman could unite, and then V1 plus man could unite, and we could use the same rules there. That is, for V2 plus woman we could use B6, and for V1 plus man we could use V5. Either way, we come up with the same sentence, although the roots are different. Now, we shall see how to determine the truth value for these sentences. Now, first let us consider that V1 loves, let us consider V1 loves some woman. We need to do it in steps. So, first, so the direction, can you see that here the direction is very important. Here the women come first and then the men, and here the men come first and then the women. The same here. So, first the women will be considered here. So, that is why V2 has united with woman, and by using rule B6, and has given V1 loves some woman. Yeah, so what is the derivation from V1 loves V2? You get by using B5, V1 loves some woman. What will be its truth value? We may remember that at each step we normally compute the truth value. The truth value of this will be 1 if and only if for some value assignment, that is V E G E V2, this one, such that the meaning of woman takes E and gives 1, that is E is a woman basically. V1 loves some woman with respect to M, and G E V2 is 1, and here we are using rule B6 of syntax and rule B6 of semantics. So, what does it mean? It means that this formula, it is not a sentence, it is a formula. Why isn't it a sentence? Because it does not have a truth value. It does have some kind of a licensed structure, but no truth value. That is the reason V1 loves some woman. If it does not have any G, so if G is removed, then this structure does not have any truth value. The moment we add G to it, it will have a truth value, because we know that G has got a defined feature, that is it assigns AES to V1, and it assigns HK to V2, and it assigns QE to V3. This is G. Now, the thing is, here the relevant variable is definitely V2, because that is varying. We are considering this part where we had V2. So, if this is phi, then phi prime is V1 loves some woman. So, phi prime is 1 if and only if for some value assignment V E G E V2, which is our relevant variable, such that this, as we know that there are two conditions. So, this is the second condition. The first condition is V1 loves some woman is with respect to M, and G E V2 is 1. Now, what will be its value? Let us see that. V1 loves some woman with respect to M, and something, whatever, with respect to M G. What will be its value? Let us try to determine. Now, it will be 1. So, V2 will collect its value, sorry, V1, here V2 is the will be 1 only when V1 loves V2. Now, this is what we have to consider. This will have a fixed reference with respect to MG. What is it? The fixed reference is always, see, V1 takes AS. So, it will be AS. So, this is true. Now, this is true, this sentence is true if and only if this sentence is true for at least one value of V2. We will see that. How many values? Once again, G. So, we once again list the. So, we can have AES V2, we can have HK V2, we can have QE V2, and we can have KR V2. So, there are actually only 4 value assignments which are relevant here, and others are the same. So, just these 4. So, first let us try the first one we have listed, or we can start with G itself. G is this, G is HK. So, G is this is a starting thing. So, we just write HK V2. What is it? It will actually be it will be 1 if and only if AS HK belongs to L. Is it true? No, we know that that is Sadi loves himself and Les, nobody else. Hence, since this is not true, this will be 1. But that is not a problem. This will be 0. That is not a problem, because there are 3 options left. We have just checked once, and the second option, I am doing it. I am doing each step of it so that we understand the calculations here. So, the next thing, once again the same structure, loves V2, and then we have the next. Let us consider this one. This is done already. Now we will do this one, M G K R V 2. So, is 1 if and only if this will be A S fixed, comma V 2 will be K R, is it belongs to L. Is it the case? No, we know that Sadi does not love Kamla. So, this is not the case. Therefore, once again this is 0. We still have 2 more options, and the next option is V 1 loves V 2 and M G. So, we consider this A S V 2. This is 1 if and only if A S comma A S is 1. Sorry, A S comma A S belongs to L, and we know that Sadi, everybody loves himself or herself. So, this is the case, this is true, therefore, this is 1. So, that is fine. So, we have got one case of 1, and so then we have just one option left. We need to consider that also. V 1 loves V 2 M G A S. No, last one is this one, Q E. So, Q E, this is 1 if and only if. Now, this case A S comma Q E belongs to L, and we know that this is the case. Sadi loves 2 people, himself and Liz. So, this is 1. We know that this is 1. So, fine. Then there are 2 cases of having this truth value, this case and this case. Now, let us consider which one, or whether both, or just one, at least whether one satisfies the second condition. We remember this is the first condition, but also there is a second condition, that is whatever. So, some of these E's, that is we have 2 E's here that satisfy condition 1, one is A S, one is Q E. At least one E must also satisfy this condition, then only this sentence will be true. Let us now consider, let us now calculate, let us see whether that is the case. Now, let us take, so this is A S, we take this value, is it true that A S is a woman? So, now we are considering this woman and A S, no, because A S, actually A S is, the name of A S is Sadi and he is not a woman. So, no, this is not true, this is not true. So, this is gone, but still we have another option, that is this. Now, we consider this woman and Q E, yes, this is true. So, now there is at least one value of E which satisfies both conditions. V 1 loves that conditions are this V 1 loves some woman comes true, and also that thing whatever is. So, one condition is V 1 loves V 2 will be 1 with respect to that value of E. Here we have 2 values A S and Q E. The second condition is that value of E, in this case Q E, must also satisfy this condition. So, it also satisfies this condition. Therefore, it is true that V 1 loves, it is true that V 1 loves some woman. Now, but that is not enough, because we have to go to the next step, which is here. Here, so this is the calculation. We may just see it very quickly. Now we are here. Already we did the rest of it. Now every man loves some woman. We know the value of this. We know the value of this much, where you have this V1. But then when every man replaces V1, it's a very different thing altogether. Now what will happen? I have written something here, but that is one way of looking at it. Also, if we want to follow the strategy of the book, then we may rewrite it this way. So we may write that this sentence, that is, every man loves some woman, one, if and only if. We started with woman and then we go to man, if and only if. As I have written, there is some value assignment GEV2 such that woman MG equals 1, for which V1 loves V2 with respect to M and GEV2 F V1 1 for I don't this is not a very good way of putting it. I would rather rewrite it. I would rather rewrite it, and yes, if and only if there is some value assignment GEV2 such that, now this will be a woman M G that takes V is 1 for which V1 loves V2 with respect to M is 1. I would put it this way, and I would erase this part here. I would like to put it this way in the printed format. For which this is 1 for every value assignment G F V1 such that now it is about man M G F equals 1. This is how I would like to put it, and we shall see how it works. What I said could be summarized diagrammatically this way. So there are two things: V1 loves V2. We know the binders. So for V1 it is every man. So it is something like all V1, and then for this it is some V2. So these are the binders, and then there are other conditions. So then this is associated with woman, and this is associated with man. So, we are listing what is there. Now, we shall see what may happen. So, now we have 4 individuals. So, and we will check each and every. We started our calculation here. So, the point is there exists some woman here such that every man loves her. That was our interpretation. So, then we just list these things, that is, we will first of all consider all the individuals here from our list. So, basically we have 2, we have this set. So, 2 female individuals and 2 male individuals, but we are listing all individuals first, and H k q e, and it is a case of, because this is sum, it will be a case of or H k or k r, and because it is a case of all, here it will be and. So, we have A s and q e and H k and k r. Similarly, here A s and q e and H k and k r. Here same thing. K r and K r. Now, this is with and, because this is all, that is every, in other words every, and because this is sum, it is sum. So, now the checking has this direction, we have seen that before. The checking will have this direction. The point is there now, not only that, there are, we need another qualifier. We need to identify women. Only they will be relevant here, because these individuals also will have to qualify as women. So, who are women here? These are 2 women in our list, that is Liz is a woman and Kamla is a woman, and here we have only men that qualify. So, here we have Sadie and Hank, Sadie and Hank. Others are there on the list, but they do not qualify because it is a man list and it is a woman list. So, we can see that this is woman and this is man. Now, the 2 relevant things we have to check. So, our checking cases have been narrowed down. This is to ensure that this is to ensure this part, this woman E equals 1, and this is to ensure the other part, that is man F equals 1. So, only these 2 satisfy that condition, and only these 2 satisfy that condition. That is why we have put it this way. Okay. So, now we shall check whether there is at least one woman whom everybody loves, right? Every man loves. Let us see. First, we consider, if we find 1, we are done. So, we first consider Liz. Is Liz somebody whom every man, is Liz somebody a woman whom every man, so the underlined things here, every man loves. So, we can see that yes, Anwar Sadat, that is Sadie, loves QE, but Hank does not. And what about this one, Kamla? For Kamla, yes, we know that Hank loves her, but Sadie does not. Therefore, we do not find a single woman whom all men or every man loves. Therefore, the truth value of this will be actually 0. The truth value here is 0, and so this is not the end of it. So, the calculation goes like this, but then the end of it will be the removal of G, but that is an automatic step. The moment G satisfies it, we can say that for all G it will be satisfied. So, the truth value of this sentence will be 0, but the other sentence, so we said that there are two different interpretations. The other sentence will be may be different from this one. The interpretation of the other sentence may be different. How we shall see that? This one is every man. So, here it is, it starts with the man part. So, every man loves V2 is derived from V1 loves V2. We can directly go to the calculation part and see how this one works. So, we just write once again V1 loves V2, and what is the point? First it is men. So, V1 goes to, so anything, all the things will be listed anyway, but the direction in this case will be different. So, then so our things are because the first one is every, so it will be AS and HK and QE and KR, and the second one, so V1 is so yeah, we can just do it very briefly. This is a case of every, and so it is a case of all X, all V1, right, because it is a case of all V1, and also it is a case of man, and this is a case of some, and this is a case of woman. Okay. So, this is there. So, here you find these things, and because this is a case of sum, we have now AS or HK or QE or KR. So, it will be written everywhere. The pen does not write very fast, that is one problem we have, and QE or KR, and once again AS or HK or QE or KR. Now, we will see that man woman thing. Here our relevant things are, so here we have men, that is these two are men, and here we have women. So, these two are women, and the calculation goes from here to there. So, first we have to come here and then see what is happening, because here every man comes first, then some woman. So, the derivation is different, that is why the direction differs here. So, now we check. Now, here it should be a case of because it is every, so and these two qualify as men. So, here it will be a case of and here or. Let us check whether this has at least one woman this loves. Let us see. So, what about, so the relevant things are these two. So, ASQE, yes, we know that AS comma QE actually belongs to the reference of L. So, this one man qualifies. What about this? Both have to, because it is a case of every. So, the second one it is once again QE and KR. QE does not, but so QE does not, but KR does. So this also qualifies, right, because we just write HK comma KR belongs to L. Because both the conditions are satisfied, we can say that the value of the final thing, that is every man loves some woman, is actually 1. Now we can see that it is the same sentence, every man loves some woman. The first interpretation actually is a false sentence, and the second interpretation gives a true sentence, but it seems to be one sentence. That is one reason logicians did not like the natural language. But now Montague has created kind of a framework to disambiguate natural language sentences. When you have some kind of disambiguation procedure, you the moment you have a device to disambiguate the ambiguous things of natural language, you shouldn't have any problem. So natural language, any natural language can have unambiguous sentences when you have the correct interpretative device. This is what Montague actually is trying to show. In the case of logic, you never had this problem of ambiguity, but here you have this problem. So that is the thing. Now after having dealt with this, we will take up a complex sentence. These are all simple sentences, they do not have any logical connective. We just consider one more example, and that will be the end of our predicate semantics. Let us consider this sentence: if some man loves Liz, then that man loves some woman. Intuitively it must be a true sentence, because Liz is a woman. So if some man loves Liz, then that man loves some woman. Here unfortunately we cannot have he, we have to have this very thing, this very phrase. But anyways, let us see. And if then, we know that if then does this, it maps 1 1 to 1 and 1 0 to 0, 0 1 to 1 and 0 0 to 1. So we know this. This is very important to know that if then assigns values like this, truth values like this. So and also there are two different sentences here. So for 1 1, so like for two different values, right, 1 1 1 0. So there are two different atomic sentences here, and this is a molecular sentence, the whole sentence. What is the derivation of this sentence? It is something like this. Let phi be if V1 loves Liz, then V1 loves V2, and then we add man, and how to derive it, man and V1, and also the rule, because it is sum, we need to derive it. We have the rule B5, B6, the semantic rule B6. So B6, this combination gives our phi prime, which is if the first occurrence, that is the leftmost occurrence of V1, must be replaced by some man, because we are using rule B5. If some man and we are using the Cn common noun man loves Liz, then the subsequent occurrences, we have this is a subsequent occurrence of V1. So then we have that man loves V2. This is our phi prime, and then we add woman to it, and we use V2 here, and once again we use the rule B6. We get then phi double prime, which is if some man loves Liz, then that man loves some woman. This is our final construction. So we have done it in 3 steps. Actually, there are many other steps, because you can have V1 loves Liz, that is one sentence, and here I just want to sort of revisit the entire thing. So here actually we have used rule, here we used rule 1 and here rule 2. So then we used here we used rule 1 and here rule 2 once again, and we have taken these two and we have used perhaps rule 5 or 6. We just need to see this, but whatever, we have used the conj rule, whatever it is, and we have made this sentence, and then all the derivation has come. So actually there are several steps, but we are just summarizing it. So so in order to determine the truth value of this, we need to determine the truth value of this sentence, and then for this the most how to say, the most basic sentence. So then how do we go about it? So first we do this one, we do phi prime, then because phi prime will depend on phi, then phi double prime, which will depend on phi prime. So remember that phi prime is where loves V2. So some man loves Liz, then that man loves V2. So we go to the next page and try to do it. So what is it? So if some man loves Liz, then that man loves V2 will be 1. We are trying to write the rules if and only if V1 if V1 loves Liz, then V1 loves V2 with respect to M is 1 with respect to, now because this is sum value assignment G prime, this G prime is actually for us now sum G, this is V1 sum G V1 such that man MG E is 1. So this is our first condition to do this one. How to calculate then this thing. Now is it true? So what is it now? What is V1 and V2? V2 will be, so what is our G? Let us remember G once again. G assigns AS to V, and other things also have to be there here. So just the value of G, V2 is HK and V3 is QE, and there are several other things. That is our initial G. So so then V2 will collect its value directly from G, and it will be it will be, we know that it will be HK. So the point is, if we find one E which is at the same time a man, and if E HK belongs to the denotation of L, then this will be 1. So how to find it? So there are 4 individuals. Let us try to do our exercise again. So we know that there are 4 individuals. So we just write V1 loves Liz. If V1 loves Liz, then V1 loves V2. This is our sentence, and V2 is just one thing, so we don't have to worry about V2. So V2 is HK, but V1 now varies. And how does it vary? All these are V1s, so we have 4 values: AS, HK, and QE, and KR. And we let us see the binders for V1. So the binder for this is sum, right? It is V1, or yeah, as we know, it is sum, and also it is man. So let's once again underline the men, so AS and HK. And so the same thing has to be copy pasted here also, because sorry, not under V2, because it's the same thing, V1 and V1 with the same binder KR, and once again they're both relevant here because there are 2 men. It's the same binder, right? So just write here the same. This is sum V1 and also man. That's the reason this value has been copy pasted here. So one set of value will come from here, and then that will be taken there. So now the point is, if some man loves Liz, so it is not just man and some, also it is loving Liz. That is another condition, right? So then let's see, is there whether there is something that satisfies all these things, because without loving Liz, the consequent does not make sense. So we also need that. So there are 2 different parts, one Liz and one HK. So yes, we can see that here, because this is sum, we have or here. We don't have and because of sum. So the point is, if one of these, that is AS or HK, that is in our language, this is the reality part. AS and HK are parts of reality, but in our language we have Sadie and Hank. If at least one of them loves Liz, then we can go to the second part. So let's look at the truth value of it. But the truth value of the whole sentence will be computed at the same time, because this very V1 goes there also. So we cannot compute the truth value at different steps. One thing must be considered at a time. Now let's see whether AS, so there are 2 things to be checked. Let us do that. So then the whole sentence first, with respect to M and G AS V1, what does it give? Does it give 1, or does it give 0? Let's see that. Because AS loves Liz, so this part, that is because Sadie loves Liz, then V1 loves HK. Is this true? Now this part, V1 does not love HK. This part is 0. Therefore this thing will be 0. The whole sentence will be 0. So the calculation, so at least for, so when we for some man, so we are trying to see the truth value of this sentence, right? That is, if some man loves Liz, then that man loves V2. So whether this sentence or not a sentence, this is still a formula. If there is no G, if G is there, then it's a sentence because V2 will collect some reference from it. But anyways, we can see that when it is AS, it is 0. Then what about there is another person who satisfies it, that is HK, that is our Hank. So with respect to this, what will happen if HK loves Liz? So this part will definitely be 0 because HK loves himself, that is HK means Hank. Hank loves himself, and Kamla, he does not love, Hank does not love Liz. This part will be 0. We need not consider this because for if then, if the first part is 0, definitely the whole thing comes to be 1. What is it once again? 1 1 gives 1 for if then, and only 1 0 gives 0, and 0 1 once again gives 1, and 0 0 gives 0. 0 0 gives also 1. So this is the value matrix for if then. So therefore we can see that if it is 0, if the first one is 0 like this, the second one, the truth value of it must be 1. So therefore this is 1. So what is then, so and we know that it is for some man, right? So if one man satisfies this, then the entire sentence will be 1. So we just write here. So other things we don't consider, so as if they are not there. The point is, what is the calculation of the truth value? This sentence comes to be 1. But you see, still this is not our desired sentence. This is just a part of it. We have a bigger thing to do. What is it? Now we have the last part of the sentence, that is this is the whole thing. If some man loves Liz, then that man loves some woman. What is the truth value of that with respect to M and G? We don't know, we need to calculate. We start. So our sentence now, if V1 loves Liz, now we write all the things we require, and for this it is a case of sum. We know it is a case of sum, and the individuals are, that's why it will be AS or HK or QE or KR. Here it is just a case of copy pasting these values. KR, and so this is a case of sum and also man, and then we have sum and woman. So all we have B6 throughout, and once again we have 4 values here, that is AS, once again sum or HK or QE or KR, and the relevant things now. It is about underlining the relevant things. So men here AS HK, and women here QE and KR. So these are the cases we need to consider. So and Liz, what is the value of Liz? We know that it is plain and simple QE. Now our checking, so there are 2 checking cases here, and 2 checking cases here. That's it. So we need to go this way. This is the direction of our whole thing. So because now there is no ambiguity, we'll see that yes, it can be interpreted in 2 different routes, but then the result will be the same. There is no such ambiguity here. So we have chosen this direction, and then we see what happens is AS loves QE. Is it true? Yes. So because AS QE belongs to L, this is 1. Then AS loves at least one woman. So now you see this is true. So because of, once again, AS QE belongs to L, this also is true. So this, the whole sentence, then because of 1 1, if then will be 1. So we can see that there is at least some man who is such that if he loves Liz, then he loves some woman. We have seen that. We need not check any other value, because one individual who happens to be a man has satisfied all other conditions. But for the sake of, so therefore this will be 1 anyway. But for the sake of understanding, we may also check what happens in the case of HK. Does he qualify? Now yeah, these are the relevant cases, and then we can check HK, he is a man, and these are all relevant cases, and HK QE, this is 0. We know that because HK comma QE does not belong to L. And then what about H? It's the same thing we have to consider, because it's the same line. It's the same line. So HK, does he love any woman? This part comes to be true, because HK KR belongs to L. Now what is the value? The value is 0 1. 0 1 for if then is 1. So in fact both the men actually qualify this test. So definitely it is a true sentence, but it is unlike the previous sentences. This one is complex. So we just wanted to handle a bit of complexity, and this is how we do it. So then this is how we have seen how this predicate semantics works. We could have considered some more examples, but maybe some other time. So so far we were dealing with the first order predicate logic. As I said, why first order? Because here all our variables, let it be L1. In the case of L1 we had x, y, z. They are, so the variables range over all names. So it was either d or n or j or m. And in the case of L1E, we have these variables v1, v2, v3, and these variables range over other names like Sadie or Liz or Hank or Kamla. Therefore this is first order, because here the predicates like loves, there is no variable for loves. There is nothing that ranges over loves or all other 2 plus predicates, or nothing that ranges over all 1 plus predicates. Now in the next session we will consider a higher order language, which will deal with predicates, which will deal with variables that range over predicates. That's it. Thank you. We meet again.